Okay, so our objective today is to solve one-step equations using addition or subtraction. So tonight, that's all that they really have on there. They may have that sneaky little -1 that you have to take care of, but most of the problems are just adding and subtracting. Okay, so solve one-step equations using addition or subtraction. Now this unit that we're studying starts off easy and gets harder, not harder, but more and more things you have to contend with. Okay, so we're going to start off with one step adding and subtracting. We'll move on to one step with multiplying and dividing. We'll move on to multiple steps of things. We'll move on to parentheses and distributing. We'll move on to variables on both sides. So we start with the basics, and then we just keep adding on to it. Okay, and just to let you know, your benchmark starts next Friday, and it's going to have a lot of equations, but we will not have covered all of them. So just do your best on the test, and don't worry about the grade on that. Okay, but you need to do your best. People are looking at the results. Okay, and the results do help us guide what we do next in the classroom. So I need you guys to actually put forth your best effort and not just randomly guess answers, because that doesn't help anybody. Okay? All right, so let me define the word one step so you understand what I mean by that. So one step means equations that contain one operation. So in order to solve with one operation, I'm going to have to do one operation to get my variable alone. Okay? And our goal is to solve for the variable. That's our goal. So let's talk about how would I go about doing that. Oh, that doesn't look right. And one step, that doesn't sound right, does it? To solve a one-step equation, you're going to, let's see, how do I want to say this? Do the opposite operation of the number that is on the same side as the variable. He's the one you want to do the math to. Okay, do the opposite operation. And what's the opposite of adding? Subtracting. The opposite of subtracting is adding. Okay? So we're going to do the opposite operation of the number that is on the same side as the variable. This is the biggie. And this is what I didn't see from a lot of you, because a lot of you were guessing the number that would take the place of the variable. We don't guess anymore. Guess and check was an elementary strategy. We're getting ready to go for algebra, so we need to actually prove out our answer. So you need to show work on both sides of the equation. Now, what I saw some people do is that they had the number on both sides, but they didn't show the operation. So I didn't know whether you were adding or subtracting, which means that you may not know by the time you're actually doing the calculation whether you add or subtract. So you better have a sign and a number on both sides. Okay, so an operation and a sign I should see every single time you do opposite operations. All right, now, how you write your answer is a very specific thing. Answer format. You're going to have whatever the variable is always on the left. And there'll be a reason why I teach you to do that because it's going to become important down the line with other types of problems. So if we get in the habit, then we won't have to relearn. Then we write equals, and then whatever the number is for the answer. Remember, the equation is asking you for what does x equal in this problem? What does y equal? What does r equal? So I need to tell in my answer x equals, y equals, r equals. Okay? Very important that we give that back. Now, the last one, for some reason, people don't want to do. And in fact, I get asked the question as soon as I put it up, do I have to do this? And the answer is, do you want to make sure you have it right? Because you don't want to find out when you get a quiz back if you got it right or wrong. You want to have confidence putting your test into the tray saying, I got it right. And how you can do that is you can check your work. To do that, you're going to substitute, oops, let me try that again. Your answer in for the variable and solve. Okay, so you're going to put the number back in. So you have a number, math, number equals number. Okay, and if you get this, if the answer on the left equals answer on the right, hold on. You are correct. Joey.
What does it say after before? What does it say after check here?
Work.
Thank you.
Now, you're going to have a couple of weird problems, not weird, but math things that you have to make sure that you understand. And they deal with two different types of values. Most people don't have an issue with whole numbers. You do have to watch out for signs. You do have to go back and review your rules for integers. If you're feeling weak on your rules for integers, go to Virtual Nerd, go to Khan Academy, watch some videos, remind yourself the rules. Okay, we'll talk about them in class, but we're not going to do a lot of reteaching. Okay, then you do have to contend with special kind of numbers like decimals. If you have decimals in a problem, what do you need to remember to do in order to add or subtract decimals? What do you need to remember to do in order to add or subtract decimals? Corey.
Have an even amount of decimals. Like the same.
Number of decimals or digits?
Digits.
Okay, so we have to have the same number of digits after the decimal. What else? Kind of a key thing. Kaleo.
When you allocate that, you have to line up the decimal points.
So first thing we're going to do is we're going to line up the decimals. So that means we're doing our work vertically, just like you should always be doing for solving problems. I saw several people trying to solve their homework or those problems horizontally. We don't work that way. Our eyes cannot catch mistakes that way. We got to do it vertically. So we line up decimals and add zeros if necessary. It'll come back. Add zeros if necessary to make values the same length. When people don't do this last step, they tend to not subtract correctly, and then they get their answer wrong. So it's really important that you remember this. So you got to line up your decimals, add zeros if necessary to make the values the same length. And again, when you're adding your zeros, you're adding it to the end of the numbers. Okay? All right, so the last grouping are our fractions. So what do we need to remember to do in order to add or subtract fractions? What's the rule with adding and subtracting fractions? Elijah? I'm sorry? Okay. All right, come on. There's a whole bunch of quiet people I'm going to start calling on. Jack, what do you need in order to add or subtract fractions? Ooh, elementary school stuff. Courtney? You gotta have the same denominator. So you must have the same denominator to add or subtract fractions. Okay. So what I want to do is 2 examples of what your homework is. You already have 4 at the top of your paper that deal with whole numbers, positives and negatives. Let's throw in some fractions and decimals and see what that looks like. So the directions you're going to see, and by the way, we're going to be dealing with the old green algebra book, so you're going to want to start bringing it back and forth to class. It's just going to tell you to solve. Okay? So let's do this problem. Let's have x minus 5.3 equals 7.2. So we locate the number that's on the same side as the variable. What math are we going to do to make him become a 0 on the left and then show up on the other side? What's our opposite operations in this problem? Okay, there is subtracting already, so the opposite of subtracting would need to be adding. So we're going to add the 5.3 to both sides. Now, this is why I do my work always vertically, because I can line things up immediately, and then I can do whatever math I need to do. Plus, I can catch my mistakes. Like if I have a minus under a minus, I notice, oh my gosh, I did the same operation, not opposite operations. So these give me 0. Opposites always add to give me 0. And then over here I'm going to add. So 2 plus 3 is 5, and 7 plus 5 is 12. So I get x equals 12.5. Now, the one thing, I don't know why, but people don't want to do a check. But this is how easy a check is. Go back to the original equation and substitute in for the x, 12.5. And find out if it actually does equal 7.2 when you subtract the 5.3 from it. So I'm going to reline these up, do my subtraction, and I get 7.2 does equal 7.2. So what I've just done is verify that yes, my answer x equals 12.5. Okay?
Do you have to show the check on the homework?
Do you want to get the answer right? Because I'm going to tell you when I give you a quiz or test, I'm not going to put the answers at the back of it for you to check to see if it's right. And again, I don't want you to find out if you did it right or wrong after I've graded it and handed back. So this is the easiest way to get yourself an A on a test, is to make sure that you check all your answers. It's a good habit to get into. All right, let's do one with fractions. Y plus 2/9 equals 4/3. Y plus 2/9 equals 4/3. So what math am I going to do to both sides to get the y all by itself? Kenny?
Divide?
Is division the opposite of adding, Kenny?
No.
What's the opposite of adding?
Subtract.
Okay, can we try that?
Yeah.
Let's do that. So we're going to subtract 2/9 from both sides. Okay, well that takes care of this business, but then we create a problem on the other side. I can't actually do the math because my denominators don't match. So I'm going to create what we call equivalent fractions. What's the common denominator between 3 and 9? 9. What did I do to 3 to make it 9? I multiplied it by 3. Whatever I do to him, I got to do to the numerator. I got to treat them the same. That's called an equivalent fraction. So what I get is 12/9. So 12/9 and 4/3 have exactly the same value. They just look differently. Okay. Now what did I do to 9 on the bottom to get to 9?
Times 1.
Yeah, or we could say we didn't do anything to it. So we don't need to do anything to the -2. It stays at -2. And now we do our math. We get y equals 12 take away 2 is 10, and I get 10/9 as my answer. So what I can do is check my work. And is 10 ninths plus 2 ninths equal to 4/3? Hold on. We get 12 ninths is equal to 4/3, but then I can simplify this 12 and 9 by 3. And sure enough, I get 4/3 equals 4/3. So what that says is I have the right answer. Okay? That's what you're going to be working on your homework.